Hello everyone and very welcome to our webinar today. On behalf of our Research Center for Spatial Data Infrastructure and Land Administration, we are very delighted to having you all with us today to hearing and also discussing about our latest work around digital twin technology. But before we start, I would like to acknowledge the traditional owners of the land, and we acknowledge that we are on the land of the Wurundjeri people, and we respect their elders past and present. But before we start running through our presentation, I would like to just remind you about 2 points. One is about we are recording this session and we will be sharing this after the session is finished. The other part is we would like to invite you all for your questions to put your questions into a question and answer chat and the functions that you have. Then we will be dealing with those at the end of the session. And we're hoping that we can cover the questions that is coming through, and our colleagues in the background are coordinating the questions, and at the end we will be actually meeting those. Thank you for that. What I would like to start with, I would like to just sharing a bit about our center, and then we're moving to some of the functionality that we are running through this. So our center is this year, we are very delighted that we are going to celebrating our 20 years in operation, and we established back in 2001, and the center is in the research and innovation, and also a strong focus on the future-proofing research. So we are also translating our research to practice and working with many international and national agencies and government agencies and also private sectors and other universities. So we have a mix of disciplines within our team working on different elements, and also we trying to always addressing the challenge from different lenses, and also multidisciplinary team that is working together on that. We also having, if we go to the next slide, please. The capabilities that we have in our centers and the focus of our work are all around different domains connected to the location intelligence. And in particular, we're focusing on modern land administration, as well as also applying resilience into the design. And in addition to that, elements like digital twin as a platform enabling and empowering different agencies and organizations, and with the different modules that we can provide to our partners and also organizations that we are serving them in. We are also focusing on sustainability, sustainable development goals as a layer that then we can measure and monitor our contribution to sustainability. And these are the elements that the center are focusing and also providing the capabilities into the market. Next slide, please. We are living in an increasingly complex and interconnected world.
Land and spatial information are critical tools to help us make informed decisions about economic, social, and environmental development.
We design and develop state-of-the-art technologies that will help achieving more sustainable societies.
We have developed a digital twin of our campus to monitor attributes such as live energy consumption, live occupancy density, asset management, space management, building information modeling, underground facilities, and live IoT data visualization.
We aim to design for the cities and the systems of the future by constantly improving our capabilities and developing new features.
Our platform dynamically aggregates data layers from multiple sources and connect them based on geolocation.
Our products provide multifaceted analytical capabilities for research and practice in areas related to land administration, urban planning, urban design, energy modeling, and infrastructure development.
We collaborate to provide focused research to deliver innovations that responds to global challenges and contributes to a smart, sustainable future for all.
So we are going to a journey from a real world to the digital world. This is the focus of this session and webinar today about the digital twin and the capabilities that have been developed in collaboration with many groups, which we will be acknowledging that. We also, if we look at to the smart cities and also we look at to the sustainabilities at the same time, applying and incorporating the resilience into this, then we can see the connection between all these components together, particularly if you are focusing on interconnected future for all. And this is one of the promises of the Sustainable Development Goals agenda. Therefore, we are going to have a inclusiveness as well as also connectivities and also resilience. All of this going to bring a location as a heart of this for the spatially enabled societies. By saying this, then we can look at to the digital twin, and in particular with the aim of the ANZLIC, Australian New Zealand Land Information Council, and the work that and the principles that have been addressed here. So therefore, from the physical world to the digital world, what we can do, and then the steps that we're going to take on. There are different elements, different forms can be done. And of course, different agencies and groups have defined this slightly different, and these are all okay, and we can bring it and different opportunities on the table here. So therefore, from our perspectives and our focus on the land, and in particular land administration and cadastre, and as a foundation for the digital twin technology, going from the 2-dimension to the accurate base map for this, and then going to the 3-dimensional parcel fabric and into the digital 3D digital cadastre. And if we did that one, then by integrating the 3D cadastre and also digital twin, which we will be showcasing today to you, then we can move from the physical world to the digital world with the aim also to providing series of capabilities and the unique opportunities that can facilitate the informed decision process, as well as also a return on our investments on that. By this, and all of the foundation for this are the base on the principles that the digital twin principles are approved by the ANZLIC. Next slide, please. So what we can look at to this as a principle, so we are talking about highly advanced digital representation of the real world, and also combining the underpinning technology and also spatial location intelligence into this. Therefore, we can provide series of insight and the opportunities that by having a live data feed into the system, and the system can facilitate and forecast and simulate the future, and then we can take the decision which we have a confidence on that. By this today, our colleagues going to present to you a number of colleagues that we have, and they put together a number of elements and case studies that hopefully you see relevance to your STEAM organization and your interests, and we would be very delighted and happy to discuss with you any elements that we might be able to assist you with. By this, I would like to invite Dr. Sohail Sabri to start and showcasing some of the elements in the urban system.
Thank you very much, and very welcome everyone. We are very delighted to be with you here and showcasing our capabilities around the digital twin. So my name is Sohail Sabri. I'm a part of the team in Center for Spatial Data Infrastructure and Land Administration, and I actually lead the application of digital twin in urban planning and design. So with that, let me explain to you three aspects outlined here. What is an urban digital twin, and digital twin for cities, how it looks like, and then what are the potential applications and design, planning and design applications that we have already developed in our digital twin. So the digital twin actually has, coined by Michael Greaves in the product life cycle management, is engineering and is actually considering the tightening the connection between design and production from the engineering perspective. So the physical products in real environment are connected to the virtual products in the digital environment. So in that sense, we actually have engineering, while in the city, as you can see in the other side of the scene, we actually have built environment, we have natural environment. There are peoples who are moving and they make decisions, and all these different entities, they have interactions. So our digital twin is different from the product. So if we move to the city scale, definitely we actually need to observe and monitor all the interactions between all city entities. We actually have we are privileged with having the new technologies, including the sensors, the IoT, and so on, and we can actually turn those into data and use that data for understanding the current, the past, and future technologies and models. So having said that, we can actually make a mirror of the changes, and based on that, we can understand what would be the impact of our decisions and our interventions to the cities. The digital twin has actually considered in different governments, like in the Britain, we actually have the Gemini principles, which is coming in the next slide, and you can see that the digital twin is considered beyond a modeling, beyond a tool, and also beyond the current technologies that is being used. The value creation of the digital twin for the entire community is very important, is considered. The insights that it generates for different decision makers, different users, are very important. And also, definitely, it should be in the federative shape, and it should be integrated with evolution. That means that any sort of technology is adding, the digital twin should be able to incorporate this. And of course, we always had the security, openness, and quality of the tools or data or analytics before digital twin as well. So all of those aspects are considered. But from the maturity perspective, which is actually something in digital twin, and we have to talk about that and we have to consider, is digital twin can start from the data, from the aggregation of different data with the different qualities, and they can go to the visualization, and they can actually be integrated for different models, and also new sort of emerging technologies can be added to be able for us to actuate and finally automate the process. And that is the time that we are mirroring the process. So having said that, we are in the beginning of the journey, and we have already done lots of work. As you know, that the Digital Twin Consortium has just started last year, and there are huge interest in the market in
in order to application of the digital twin in different domains. And urban digital twin definitely is one of those aspects that we are going to talk today. And talking about the planning and design applications of the digital twin in the next couple of slides. So let me start with a snapshot of what we have developed in the urban digital twin. The urban digital twin actually has started with consideration of different, urban planning and urban design activities, and helping the decision makers in different groups, including the statutory planners and strategic planners, to leverage the new technology for their day-to-day activities. So the digital twin should be able to be helping the planning decisions based on the rules we have. It should be helping the designers even before submission for planning to run the context analysis and check the compliance of the assessments through the visual or rule-based. And also it should be helping the strategic planners to see the impacts and implications of their decisions in different contexts. So if I move to the first application type, which is development envelope control. So in that, we actually developed a number of tools and a panel dedicated to this development envelope control in order to be able to visualize the design and development overlays and make a 3D visualization on that. And based on that, we should be able to move from 2D to 3D, and that 3D, those are building envelopes or development envelopes, and they should be disconnected based on the different features in the building in terms of we actually have different terminologies such as the base or tower or podium. So we should be able to make changes. And if you actually see in the next slide, you can see that the development envelope control will be helping us to make changes in different scenarios. We can actually look at different building shapes and morphologies that we make based on our decisions. We can search and query and see how different building envelopes will give us in terms of yield of the interior and exterior. The impacts can be actually queried in terms of the number of floors, the number of units, and also the implications in terms of the shadow impact, as well as the solar access and so on. So this will be helping us to run a scenario based and also checking every implications from the environmental or from the number of users or the activities generated in the area. Another aspect is about the architecture concept review. So the architecture concept review is the initial part before application for the planning. So here we actually brought the University of Melbourne's mass architectural design in the Fisherman's Bend, as you can see here, is overlaid with the planning zones and the planning scheme overlays. So you can actually easily look at the architecture building in that area and then understand what sort of planning schemes are applied here. And also you can actually have a quick understanding of the visual impact of the mass building in the entire area. So this will be giving us, from the planning perspective and also the architectural perspective, a better understanding of how we can actually design a building or a group of buildings in order to considering the neighborhood character and the future implications of the building. Another aspect of the digital twin having the third dimension in the visualization. The third dimension here is about the integration of the BIM data with the GIS. This will be explained in more detail later on by our colleague Dawood. So what I want to raise here is that this technology, having beam data for planners, will be helping to understand what is the visual impacts. In fact, the Minister for Planning, as you know, in Victoria, they actually they are responsible for improving the high-rise buildings or buildings above 25,000 square meters. So this will be very useful to checking for the building compliance and then visualizing rather than using the stack of different sort of tools. You can actually extract, make query on the building attributes, including the price, the type of the activity in every floor, and also definitely it can be useful for strategic planning, understanding the demand that a building will be generating for the future, and that can be useful for I mean the social infrastructure development, physical infrastructure development, as well as environmental analysis and understanding what would be the future like. So having said that, we actually have another aspect in the digital twin, which is scenario-based planning and analytics. So in our digital twin, we have created a capability for urban planners and designers to make modifications in urban scene, and based on that, examine what would be the impact, like impact through the open space appraisal, and also checking the view of a building to the other, as well as checking the future developments like the pressing structure planning to be integrated with the current situation, and combining that with the building approvals, so that that will be showing how we are complied with the developments, and how we are going to develop the future based on that. So with that, I stop here. I will be happy to answer the questions at the end of this session, and I will hand it over to Dr. Benny Chen. Thank you very much.
Good afternoon, everyone. My name is Benny. I'm an architect of the CSDILA digital twin. So in this session, I'll just talk about how the things works. So when we design the digital twin, the philosophy behind is we want to build not just like an isolated system. We want to build a highly customizable and open ecosystem. So that means everybody can bring their data sets, bring their models, or even bring their own scripts to our digital twin platform. So and then we can utilize the digital twin to do the visualization, to some simulation, and also through a lot of analytics. And then we can get some insights about the data. We can learn from the models. We can get more and more intelligence, and eventually we can get a lot of knowledge from the data and the model people bring to the digital twin system. Next page, please. So here is the overall architect, or the key component of the digital twin on our right-hand part. So there is a digital twin data portal. So here we are talking about 3 different types of data so we can bring to the digital twin system. At the top is the traditional GIS spatial data set. So we support the shapefile, geodatabase, GeoJSON, the TIFF, rasters, and if your data set is already online, for example, can be accessible through the OGC standards like WFS, WMS, that would be ideal. So you can directly plug in all this sort of information into our digital twin. The data doesn't need to be uploaded into our system. It can be served from remote or distributed data centers as well. And we also support many different types of 3D data formats. So for example, we are enabling the terrain models, the DEM, and also supports the 3D point cloud, the photo mesh. And more recently, we support the FBX, OBJ, and of course, the Beam RFC files. And all these sort of three different types of 3D data models will be converted into 3D tiles format, and we will be visualized and in the digital twin front end. And we also built many different connectors to listen to different data sources in real time. For example, we have built a live data connector listening to the emergency management Victoria's live feed, live incident feed. And we also connect to the Bureau of Meteorology, their real-time weather information, the air quality. And we also connect to the live traffic information and also the live tram data. So I will show you guys this sort of things in a minute. On the other end, we also built the digital twin, which can work with the IoT, the sensor networks. So all these sort of the IoT data will be streamed directly into our digital twin and through our real-time analytics engine. And we can do the real-time analysis. The data doesn't have to be stored in our database. So we just do the analysis in real time, and then we get the knowledge. And so once we have all these sort of data sets ready, so we can build different types of analytical tools. So currently we have, for example, the building energy index tool, the occupancy tool, and the quantitative shadow analysis tool. So all these tools are built and implemented in our system, so everybody can give it a go. And as I said, we want to build like an ecosystem. So if, for example, if you have some knowledge about writing some like R code or Java code, so you can upload your script into our system. So, you know, and we treat these sort of things as like a plugin. So every users in the entire digital twin platform can start using your plugin, and you know they can get the data from digital twin and do some analysis using your algorithm or your script. So we have the data, we have the model, and we also have a really good comprehensive like a user control and a user management panel. So in our digital twin, we have different user groups. User groups is a really good concept. So for example, we can create a group user for a specific organization, and all the people in that organization can have access to some specific data set. And all the data resources in the digital twin can be shared with specific user group, and it can also be shared with specific user. So we have this, the data owner or the model owner, they have this sort of full control, you know, how the data and the model can be shared with which user or which user group. They are all fully supported currently in our digital twin platform. And we also want to build the form easily for future expansion. So we have designed some highly customizable panels. So that enables us working very, very flexibly with different partners. So I will show some examples in my live demo. So my live demo contains 3 parts. So first of all, I will show you guys what is the system user interface looks like, and some basic you know, interactions with the system. And then I will show some examples how we actually bring your data set into the system and how we actually do the visualization analysis inside the system. And eventually I want to show you, you know, how we actually utilize and integrate some live streams, live data in our digital twin system. Okay, let me share my screen. Can you see my screen? Okay, so this is how the system looks like. So first of all, it's like a fully 3D environment. So when we build this system, so the 3D is one of the main requirements for the digital twin, and because we want to support 3D and data visualization. So here we have some top menus here. There's many useful buttons. So the first one I want to show is the base map. So we support many different types of base maps. And for example, if you have like a near map, and so if you got like a near map like a token, so you can easily add your here map data set into our digital twin system. Just take a while to load the data. And also, we can also load like a historical data for a specific region. So you can also upload your own area images data into the system. So when we create this the digital twin system, another important concept is a case area. So currently what I'm showing here is the city in Melbourne. So actually in our digital twin, so we can define the case area in many different ways. So you can create some case area by yourself, or you can, for example, if I want to go to the local government area, I can just search, for example, Moreland, and then you can just click, and it will shift the case area to city of Moreland. And you can also go to like different capital city, right? So it's quite flexible. So you can define different levels of case area. And because once we define a case area, so the data will be loaded based on the case area you selected. So let me just go back to Melbourne. Yeah. So if I go here, so if I go to, for example, so here I go to the Fisherman's Bend, and also let me go to Melbourne again. Yes. So with this sort of case area, we can actually narrow down to a specific region, and then we can upload our data and then start doing analysis for a specific area. So I can also show some nice features. For example, we support some like join capabilities in our digital twin. So let me just turn off the layers. So here, for example, I can do a 2D or 3D polygon and drawing. If you double click, so it will complete the boundary. And here, because we want to do a 3D, so let me just put like a height, 100 meters high, and I also put some height underneath and the ground. So then we can create like a 3D object easily on the map. As you can see, it's also got underground part as well. So what we can do here, we can easily, for example, select it. Or we can also delete it as well. So we can select and move it, and we can also, for example, make a duplication with the model, putting a different place. If we enable, for example, the shadow, so we can directly say the shadow effect on whatever the 3D object we created here. And then we can easily delete it. Another important features in the digital twin is we support some mainly real-time 3D analysis capabilities. So let me just turn on one of our 3D data layers. Let's go to the City of Melbourne photo mesh. So the 3D photo mesh was created by City of Melbourne and is free for download. We incorporate this data set into our system. The resolution of this data set is not great, but we can certainly bring more detailed information and detailed 3D photo mesh into the system. Let's see here, it's just kind of loading. For example, if I go to here, the measurement tools here, so there's some important 3D analysis component here. The first one I want to demonstrate is like the 3D and the line of sight. So just imagine you're standing at the top of one building. So you click for that one, and then you can draw a line. You can see, and then we can say, you know, from that specific location, if you are looking at a different direction, so what is your side of view, right? So you can see here. So if nothing is blocked, so you can see this sort of like glowing white lines. So if some part has been blocked, let me just create another one here. Here, yeah. So you can say the red line here means this part is invisible. You cannot see this part of line through that specific point. We can also build some view shed analysis as well. So if let me go from choose a small lower building. Let's say here, if I want to put my viewpoint here, looking at a different location. So it will show you in different colors. All the green area will be visible from that specific point. All the red ones, that means the black point from that specific observation location. So this is some basic 3D analysis or 3D visualization tools and directly provided in our digital twin. And if I go to here, so on our left side, we can see many panels here. So they are data panels, analytics panels, 3D cadastre panels, and all these panels are flexible, so we can create easily. For example, if you have you want to utilize our digital twin for your own organization, we can customize easily and create different panels for you, and all the functions, the UI can be highly customizable and to support your specific requirement. So here, if I go to the data side, the data panel. So here, this is a very important feature of the digital twin. So this is how we can actually bring more data sets and do the visualization in the system. So if I go to the data explorer, so you can see here we have two tabs here on the top. So here is the public data list. So currently we have thousands of data here. For example, if you want to search like income, it'll bring all these sort of income related data sets to the system if you want to search like water. So all the data sets are can be created and shared by different users. So once the user can easily bring their own data sets into the system and share with different user groups. And as long as you are able to access that specific layers. So this is all the layers only accessible to the current login user. So, but how can we actually bring the data set into our digital twin? So on the second tab here, so from this user interface, we can see currently we support the WFS, the 3D tiles, and the CZML. So if you are familiar with the OGC web feature services, so you can, and if, or for example, your organization have already got like a geo server or map server, which can already put your data set online through the WFS protocol. So you can easily do this. I can just quickly show you an example. So let me create like a WFS data source. Let me just call it DT data server 3. So this is one of our data servers. And the organization is the CSDILA, and the WFS URL. I just copy and paste it here. So this is from our own data server. And if I click OK, so you can see I just registered this data source here, and all the layers will be automatically harvested into the digital twin. So here we can see this. If I want to put this layer into our system, all you need to do is you can activate this layer, and then, for example, here you can put you can, for example, add some titles. Let's say version 2, description, version 2, and more importantly, you can put many metadata information at attributes level for this specific layer. So I just leave this blank and I click save. So now the data is available in the digital twin, but it hasn't been shared with anyone, so it's still not accessible. So what you're going to do here is you can go to the access config. So from here, you can say, I want to share this specific user to which of the following user group. So I want to share this data with a domain user group, and I also want to make the layer totally accessible to the entire public user group. So if I have these two options selected, if I click OK, then now your data will be available here. Let's say UM. So here we go. So this is the layer I just created. So once I create this layer, so I can add it to my own data group. So you click this button here, and this is your data layer display name. And of course, you can put some filters on top of your layers if you know exactly what the layers contributes looks like. So you can construct a filter to create like a subset of your layer instead of loading all of them. So here, there's some previously created user groups, but you can always create a new one. For example, data. If you click OK, and then you can close this data explorer. So the newly created the group will be at the bottom of the layer. Okay, let me just turn off the 3D layers. So now the next step is how we're going to visualize the data inside the digital twin. So if I click this button here, so you can see here, this is the data layers which we just created. It's right, turn it on and off. You can see the differences on the map. And we can also see the legend here. This is like the default legend, and the system automatically created. But you can always create like different styles, right? So you just click this button here, and you go to the styles. Let's say I want to create like a red style. Single color. Go to the red one, and if I can leave the rest untouched, and if I click save, immediately a red style will be created. And of course, because this building layers got some height information, so you can certainly create a 3D visualization for this layer. If you go to styles again, if you create a new style, now this time I create a new style called by height, and then we choose different different visualization type, because the height is a continuous value. So I want to create like a graduated style color scheme for this one. And then I can choose which attributes the height is, put it here, and then you can pick different color ramps. If I go to the blues, and also you can define your classifier functions, Jenkins equal intervals. I just go with the default Jenkins. And this time I want to make my outline in white. And here, if I click this button, the 3D view will be enabled. And then we can determine, okay, so I will ask the system to extrude the building based on the building height. And so this is how you actually do the trick. You click save. So everything will be directly uploaded and visualized on the map. And if you click any of these buildings, you should be able to say the attributes. Yeah. Okay, so this is how we actually bring your own data sets and do the visualization in the digital twin. So the next, I also want to show you guys how we actually integrated and visualized the real-time information inside the digital twin. Let me just turn this off. If we go to the left panel, there's one tab called the live data. So here we have already integrated several live links. For example, this one, the CCTV camera. So all this sort of information are directly synchronized from the virtual CCTV cameras. So if I click, let's say any of them, able to just refresh it. Live data. Yeah. If I click any of them, so we can see this the live images, because the CCTV cameras, it doesn't really give us the live video streams. It gives us the static image, which is updated every 2 seconds. So if I click here, yeah. And we can also bring some the true video streams. So this is like a public accessible camera, which is in Marina Reserve. So we can see how it works. You can see people actually playing the playground. So this is the live CCTV. And we also have integrated, for example, the PTV tram data as well. So if I turn on several lines here, so the data provided by the PTV, which usually just give us the current location of the tram, but in our system we actually do a little bit more. So what we did is we bring the data into the system, and for example, each tram. Let me just make the background a little bit black and white, so we can see have more better contrast. So what we can see here is that many trams has already been loaded on the map. So as I said, the PTV data set only gave us the tram's current location. But so we did a little bit more. We know the historical data of the tram, how for example, the speeds, and there, the stop patterns, and then we do a little bit of simulation. So currently this system can support up to 20 minutes simulation. So here on the bottom, we have like a timeline controller. We can actually make the tram moving a little bit faster. And we can also drag the timeline back and forth. We can fully control the movement of the trams. So, so all these sort of the track movements, it's like we are predicting the tram's location in the next 20 minutes. And the system will automatically calibrate these sort of things every 5 minutes to say, if everything's still, on track. So if we click, for example, the trams, so we can see all this sort of information about the tram route, the next arrival time. If we click, for example, the route, it gives you the entire information of the tram route as well. So this is the live PTV tram data. We also collaborated with Here Map. They provide us with some awesome APIs for the urban area, the live traffic. So we support 8 capital cities, and for example, the city of Melbourne, and we have 3 different like live traffic attributes. For example, this is my favorite one, the jam factor, and then we can say, okay, what is like the tram the jam factor in the Greater Melbourne region in the last 30 minutes. So if I click OK, so the system will bring me all these sort of things in live. So if I zoom in a little bit, so you can say, if I make it running, yeah. So you can say it actually changed over the time. So probably just running too fast. Just slow down a little bit. So the system actually aggregates all these sort of traffic line segments attributes at every 10 minutes, and then builds this sort of heat map to reflect the traffic jam factors and visualize on our system. And so this is quite useful. And if I want to go to, let's go to Sydney. So I do the same thing for Sydney. Yeah. Now it's coming. Yeah. So basically, all this sort of live information, they are not just the images. We actually have the true data behind it. So that means we can do many analysis in real time, particularly if, for example, the traffic, if the real-time traffic data is related, so we can do a lot of analytics based on this sort of attributes to support like for different like planning scenarios or different like designing scenarios. And we also have, for example, connect to the Bureau of Meteorology. So we got the satellite images from them. So this is updated every 10 minutes, and they provide high resolution satellite images, and then we download all these sort of things, and then we create this sort of animation and visualized here in our digital twin platform. I think I have to stop here. So I will pass the presentation to my colleague Dawood. Thank you. If you have any questions, I'm happy to answer in the chat.
Thank you, Winnie. Good afternoon, everyone. Now I'm going to talk about data capturing and visualization. So far, our colleagues discussed about the digital twin and how we can bring the data sets into our digital twin platform, but the question is how we can capture the data sets. So we have a city and we need to capture a sample of the city. So we need to create like a replica in like a virtual mode in order to bring the data set into our platform. But the question is how we can bring the data sets. So I classified the data capturing method into 3 categories. So the first category, actually, we are looking at the methods for capturing above ground and outdoor. In the second method, or the second approaches, we look at the below ground, and for the third method, we just look at the methods for capturing of indoor environments. As you know, for above ground and outdoor, there are lots of different methods. We have traditional and new modern approaches. For example, we can use LiDAR, which is a method for capturing a larger scale, for example, a city or like a whole state or jurisdiction or a whole country. So we can have like an airplane with a laser scanner, and we can capture the whole area. Similarly, this is we have another approach which is called photogrammetry, and it is mainly based on capturing images. And by stitching these images together based on photogrammetry methods, we can create a 3D model. So these images can be like oblique images in order to capture the facade of the buildings. So if we, for example, use drone, so we can, for example, we can use laser scanners, or we can use photogrammetry cameras with drones, and we can capture lots of images. And by using different platforms, we can bring the data set together and create like a 3D model for the area. In addition, we can use mobile laser scanners or terrestrial laser scanners for capturing all objects which are outside of the building. So for example, in this method, you just put a laser scanner, you mount it on the car, and then by moving around the streets, you can capture the data set. So these are like the methods for above ground and outdoor. And as you know, we have like traditional methods of surveying. For example, we can use total stations or some other methods for capturing the indoor environment. For below ground, we can use different techniques, and these days, GPR is one of the techniques that is based on radar, so it is ground penetrating radar, and by sending radar signals to the objects which are underground, you get the reflections, and you can process the images and determine the depth and also the thickness or the diameter or any sort of information that you have. But these are like, there are some restrictions for these methods. And also you can use electromagnetic locators, and these are like sensitive to metal pipes or cables that you can detect for the underground assets. If you look at the indoor environments, so we can use like terrestrial laser scanners, and we can capture indoor environments. There are new methods that you can use or technologies that you can use, and they capture billions or millions of points, and you can process them to create a 3D model from the point cloud. And also we have handheld laser scanners. They have the same technology, but you can move the laser scanner, and by moving to different areas, you can capture point cloud, and then you can create a 3D model. And also we can use image-based methods in the middle. So you can see the Matterport camera, and this is based on image-based techniques. And by putting these images together, you can create a 3D model. I have an example here. I just try to open it and share the screen. And so we captured more than 30 spaces at the University of Melbourne. So I'm just going to one of those. Perhaps I can show you the Wilson Hall. Not this one, actually, the next one, which is one of the biggest hall that we have. So if I go to this view, so you can see this is a 3D model of the Wilson Hall. In this method, you can easily move around the area. And also it is possible to do some measurements, and also you can use virtual reality technologies in order to see these 3D models. And these 3D models can be import it into different applications, and we can visualize them in, for example, our digital twin platform. So just go back to my slide. Now we have captured the data sets. So we have, for example, we have 3D building models, or like building information modeling, or BIM files. We might have underground utility networks. We might have a live data set, as Benny showed. And also in, for example, in city councils, we might have lots of like GIS and CAD files, IoT sensors, DTMs, which are digital twin models, databases, point clouds, and so on. So we need to integrate these data sets together to create like a 3D model, a city. So as you can see, for example, this is a 3D city model of Melbourne, but how we can put these things together. So as Benny mentioned, we have lots of different file formats based on different standards. So we can integrate different file formats, services, databases, and different sorts of information together. We can process, prepare, integrate model hosts, and publish them into different environments. So those can be published on web-based platforms, or they can be like on virtual reality, augmented reality, and even on mobile devices. Here, as you notice, Benny presented the web-based version on the top left, but also we can visualize these datasets on mobile applications. For example, you can use iPad and you can have access to that platform, and you can visualize the datasets, and having access to those can help you to do lots of like analysis and activities as you require. In addition to that, we can use the new technologies like virtual reality technology in order to visualize the datasets. For example, you have a BIM file or you have a point cloud, you can bring them into or virtual reality platform, and you can visualize them and interact with those sorts of like datasets. You can use virtual reality headset to walk on the streets or walk into indoor environments. There are lots of functions in this platform. So you can do, for example, you can do measurements, you can select objects, identify and get information about those objects, and you can, for example, do some sort of like cross sections and some other sorts of like activities that you need as part of your requirements. And also we can use them for scenario modeling. For example, you can put the proposed development and look at it from different aspects, from, for example, from the shadow side, like from the open access and some other sort of like conditions that you have as part of your organizations. And also they can be used for predictive modeling, for example, for traffic, for the crowd management, etc. Those can be utilized. Even for event planning, those can be utilized. For example, for the New Year's Eve, this platform can show you how those platforms can be utilized. We have Milad with us, so later on he will present some of the applications of crowd management as well. These systems can visualize major infrastructure projects. So for example, if there is a new highway or a new bridge or like underground tunnel, those can be visualized with virtual reality. In addition to 4D, in addition to 3D, we can visualize time in order to visualize changes in the time. So those are possible in our virtual reality application. In addition to virtual reality, we have augmented and mixed reality applications that we are developing and working on. So using these technologies, you can visualize various datasets, especially for cadastral purposes. For example, you can visualize cadastral boundaries, easements, underground assets, or what you have. And those can be superimposed into real environments, and those can be visualized. And you can add lots of functionality on top of that. For example, for measurements or for moving objects, you can use these technologies. And recently we developed an external, highly accurate external GPS. So that device can be connected into your augmented reality device and application and can provide you with accurate, up to 1 centimeter accuracy for different purposes. This is a new technology which is called hologram table. So we recently purchased a hologram table, and we are going to launch a digital lab, and Abbas will talk about that one as well. So as part of this digital lab, we can visualize massive data sets, for example, any sort of like beam files, point cloud, above or below ground data set. Those can be visualized in this platform for different purposes. So you can have the entire city or country for modeling and visualization. Now I'm handing over to my colleague Ivo, and Ivo is showing us some of the capabilities that we have in our digital twin for visualizing and querying of massive data sets, for example, big files. Over to you. Thanks.
Okay, thank you, Dawood. Okay, right now you can see this is our web version of the digital twin. Let's go to the 3D class part. So we have several building models here, but some of them are quite credential. But today I can show you one example that is a hotel building, and all the structure is public available. So I have previously loaded the data sets here. You can see here, you can see probably 3 different colors. So the green one is the common property space. The blue one is the lot space. And the gray is the actual building structures. So in here, we have different type of classes or types. You can turn off. When I can turn off the space, or I can turn off some walls. And to do the query search, we need to go to the RFC space cadastre search. So we have different attributes for searching, like property value, level, area range, multi-range. Also, you can search the name, any type, city views. Let's have an example. For example, we want to search a property with the mortgage from Commonwealth Bank of Australia, and the value is from $500,000 to $1 million. So click search. Now you can see we have 3 results find. The highlighted are the filtered results. And if we click one of the property, we can actually bring more details. And then we can see here, the bank is CBA. Oops, the wrong one. So besides for this query functions, we also have a lot of tools for this 3D class part. For example, the style. We can create different styles. Let's create a style based on the motif. For example, we can choose the color RAM, choose a value as motif. Let's give it a name like back and click save. Now you can see the different spaces are categorized. So here is the legend. And besides the styling tools, we can have explored view, which will expand the whole building, and you can see some more details. For the demonstration, we also can use the rotation view. So you can see the all around 360 degree of the building. Okay, let's stop the rotating. Put it back. Let me put it back. For the clipping view, so clipping view is more like an inspection tool. You can check inside of the building. So here we actually can see a lot of loft spaces, stairs, and walls. And I think during this our webinar, I think George asked for the underground visualizations. In here, actually, we do have an underground. If I change the transparency of our base map, you can see actually this building comes with a basement. And we also have some data sets that is related to the underground. For example, pipes. Let's find where it is. Here. So here are two different pipes. Their color is different because they use different materials. And you can click to inspect these pipes. And this one material is VC. And let's change another one. This one material is RC. Oh. All right, thank you. Thank you for all. Let me hand over to Dawood.
Thank you very much, Igor. So just continue to the next slide. Now we have started a project at the University of Melbourne with collaboration with other universities, and as it is as part of Building 4.0 CSA. The project is called E-Planning and E-Approvals Project, and in that project, actually, we are looking at the whole process of getting planning permits and how those process can be optimized by implementing some sort of like automatic validation that you can utilize digital twin platform and implement these rules inside of a digital twin platform that can assess your proposed development, and then it can give you some sort of like reports as part of the planning and other regulatory schemes. So it needs lots of like data integrations and implementing lots of analytics and lots of like different activities. And also I have a PhD student at Lowell University as well, and he is also working on this domain as well. In addition to what we discussed so far, we also have like major infrastructure. For example, we have tunnels, we have highways, we have like lots of like big infrastructures. So this digital twin platform can be utilized for visualizing these massive actually infrastructures and the assets that we have, for example, for the whole Australia or the whole world. So those data sets can be visualized and queried in this application. And based on the needs, these queries can be customized to cover both above and below ground assets. So this system can be like a decision support system that can be used for different applications, for example, for monitoring the project progress using CCTV cameras or IoT sensors. It can be utilized for disaster modeling or simulations using the sensors that we can implement into the platform. And also it can be used for different analysis like workability assessments that, for example, city councils might need to do. So by having these sort of like technologies, we can use this platform for interactive visualization for technical discussions and community engagement as well. And also, as you know, about sustainable development goals defined by the United Nations. So this platform can be utilized for these sort of assessments. This was my last slide. Now I'm handing over to my colleague, Dr. Behzad Smanji, to continue his presentation.
Thank you very much, Dawood. Hi everyone online. I hope you still have enough energy to continue this presentation. I'm going to talk about energy in more detail in a few seconds. So my name is Behzad. I'm a lecturer in Department of Infrastructure Engineering. My main area of research is on building energy management, district heating and cooling systems, and green buildings of future. Next slide, please. So my colleagues have covered many aspects and attributes of buildings. I'm going to talk more specifically on energy and point of view of sustainability that we want to consider for our cities and cities of future. But the question is why buildings are important and why we should monitor their energy consumption. Currently, buildings are identified as the biggest energy end user in the world. The International Energy Agency, IEA, has basically reported back in 2018 that the buildings and construction sector associated with the buildings contribute to around 36% of the global energy consumption and about 40% of the CO2 emissions. So basically, they are important. We need to monitor them. A significant part of the energy used and used in the building is associated with attributes such as building operation, and basically it's, as we know, it's more like toward heating and ventilation system. We call it HVAC systems. And in Australia, basically the commercial buildings alone are responsible for over 34 megaton CO2 per year, which is a substantial number. So again, we think that digital twin and digitization will actually provide an opportunity for us in order to be able to pay closer attention to this sector, which is a very important sector. So definitely we need to know where the energy is being used and how we can prevent the energy of being lost. Next slide, please. Well, yeah, that's okay. Generally, buildings use two main sources of energy. Either they are using electricity or gas. In Australia, we have a very good infrastructure to capture electricity consumption in real time. However, for gas, still we have manual process. So it's still a process which hopefully in near future we can get to that digitization of the gas consumption as well as water. So again, what I want to talk more in the following slide is more like on the electricity side. Basically, this graph shows the electricity consumption in a typical day in, and this is a summer day, in a commercial building. By looking at the graph, you can see the demand is changing and fluctuating every hour, but then by a closer observation, we can see that the different times of the HVAC system which is being used. So for example, for the first line, you can see that this raise shows that the HVAC system has started, and then we can see actually a lunch break there, and then HVAC system turn off, the facade lighting is coming up. So there are a number of tools available for monitoring the electricity consumption. One which is rolled out across the state at the moment is the smart meters. Could you go next slide, please? And you should have seen already one of the smart meters. They come in different shapes and generation, but all of them basically have the same functionality. They read and report electricity consumption in real time. However, they have some limitations. The data flow only in one direction, from the meter to the utility provider or to whoever is actually collecting and monitoring the data. And of course, due to the security issues, the data is not accessible. Basically, owners of the buildings can have access to their data, but the data is not accessible for real-time monitoring and observation for a wider audience. The data is not cleaned and it's not verified. So we don't know if the functionality of the building has changed, and that's where the energy is changed, or we don't know how many people are actually using that facility. Therefore, smart meters are great, but definitely we need to have more devices in order to be able to collect the information required in order to be able to do that energy management or particular energy management that it is expected. Over the past 4 years in the Center for the Special Data Infrastructure and Land Admin, we have invested in various applications of Internet of Things devices. Next slide, please. This is a bit busier slide, but I will make it a bit easier for you. Basically, the way that the IoT devices are working, they generally have a sensing part that the box on a right corner down. That's a hardware, that's a sensor that you can see. We have tested various devices over the past few years, and that can measure attributes such as energy, occupancy rate, to be able to develop correlation between building operation and building demand. So we want to know if a building is using too much energy, is it because the building is terrible in terms of energy efficiency, or actually there is so many people there, or actually there's a function there? By just looking at the data coming from the smart meter, this is not possible. So that's why we need to have different layers of information that we can add to this. As Dr. Benny mentioned before, the digital twin platform also provides the opportunity to overlay different data sets together. So that's why we're actually trying to capture and harvest that capability and get it to good use. We have sensors to measure indoor air quality attributes such as temperature, humidity, and CO2 concentration, as well as particle matters. Actually, few of our sensors has been used during COVID crisis in one of the COVID wards in order to identify the likelihood of COVID droplets movement across the hospital. So IoT devices can give us a new pair of eye in order to observe in real time what will happen. And then basically all of these sensors will send their data to a gateway, and from the gateway it will go to a cloud, and then it gets to the application layer. And that in the application layer, that's where the data is accessible, and we can use them in order to run analysis and in order to run different functionality on that one. Could you go to next slide, please? Yes, click. There are many types of IoT connectivity solutions available. They vary from low data rate and low coverage range, such as Bluetooth devices, to high data rate and much longer data coverage, such as LoRa and 5G. Over the past couple of years in the center, we have invested a lot on different type of these devices. Another characteristics of IoT devices is their latency. Click, please. The latency varies from order of minute to, in the Bluetooth devices, for example, to less than microsecond in 5G devices. So far in the smart building applications all over the world, IoT devices are designed for low rate and high latency applications, such as monitoring temperature and humidity, or monitoring the occupancy density in the building. Unfortunately, the IoT devices has not yet been captured to their full capabilities. Therefore, there's a lot of opportunity for us in order to do more research and do more work, especially with industry partners and especially with city councils and state government, in order to be able to roll out applications of IoT devices which actually require higher data rate and lower latency, and then we can actually capture the opportunities that we have by rolling out of the 5G devices. Next slide, please. However, if we want to truly achieve smart buildings, we need to start moving from local operation system, just like BMS or building management system, and move toward a real-time cloud-based system. The smart buildings need to have reliable and accessible automation system, need to be adaptable, and should help improving the efficiency of the system. Smart buildings not only should be able to perform their intended task, but they should be able to adopt and adapt to the need of the users in a real time. So this gives a true meaning of a smart building. This is where opportunities for smart energy management, smart facility management will emerge. These are the new terms that actually you have seen and you have listened in the market these days. There's cloud-based facility management, cloud-based energy monitoring, virtual energy management. So these are actually terms that are booming in the industry and creates the opportunity in the digitization era in order to capture the full functionality that we have in front of us. In the center, we are investing on various applications of IoT devices for a smart city, smart facility management. We have connected these real-time data sources to BIM and digital twin to create an immersive experience for users to operate different systems on a single platform. So we have, as Dawood was showing, we have CCTV, we have train, we have trams, everything you can see in one platform. And this is actually very important for someone who is in the role of a facility manager of a building or a cluster of a building or even a campus or even a city. You can see and observe and monitor the effect of one attribute onto the other one. However, we know that moving forward, we need to incorporate more machine learning and artificial intelligence to be able to carry out the routine task to further improve the adaptability and usability of a smart building. In the next slide, I have a 2-minute video that basically shows a demonstration of one of the projects that we have done for the University of Melbourne. Could you pause the recording for now? And then I'll just give a little bit of information about the video, and then you can play the video, please. As a demonstration of our capability, this digital twin for the Parkville campus has been developed, and we had a partnership with the Chancellery and some of the industry partners, where we collect, analyze, and visualize attributes such as energy, occupancy, indoor air quality, and operation schedules. For those of you who have worked with real-time data and have experience, you know simply that comparing 2 different data sets and comparing 2 different buildings are not an easy task. Therefore, we need to create a normalization. We need to normalize the data that we are actually capturing from different sources in order to be able to make that apple-to-apple comparison. We have used national standards such as TEFMA method to calculate the space utilization, and we adopt international standards such as United States sustainability goals in order to be able to map activities across the University of Melbourne against the UN SDG goals and activities. Could you please play the video? So the first slide was actually showing the building energy management that we have identified. Here is the space utilization, and basically we have used TEFMA calculation in order to calculate what is the percentage of the usability of each of the spaces. And of course, you can zoom in and zoom out, and you can go inside the building. You can slide one floor out in order to see what is happening in that building. And then you can put it back and go continue. We have captured real-time occupancy data by using the various technologies, and we have merged that into the digital twin of the campus. And of course, search functionality was another thing that we have identified. And again, it was mentioned by Dr. Benny before on how we can use the search function in order to identify the spaces that we are looking for. Thank you very much. If my research is of your interest, please feel free to contact me directly. I hope you can enjoy the rest of the webinar. I'll pass it to you.
Thank you very much. Good day, everybody, and pleasure being with you today. My name is Milad Haghani. I'm a research fellow at the University of Melbourne. My research focuses on various areas of safety and transportation, particularly areas that are related to human behavior, human factors, and agent-based modeling. So in this part of the presentation, I'm going to talk about issues related to crowd management with you. As Abbas pointed out in the introduction, one of the key aspects of sustainable cities and sustainable development of cities is the fact that cities are getting more and more populated, and as a result of that, issues related to crowd management have become highlighted and have been brought to the attention of researchers more increasingly in the recent years. So we have been witnessing incidents around the world, for example, in religious gatherings, stadiums, and more recently in Australia during music festivals, that have highlighted the fact that the mismanagement of the kind of repercussions that would result from the mismanagement of crowds and lack of preparation when people gather together. This research ranges from any context, including indoors and outdoors, where large numbers of people gather together. And at the heart of the research is situations where we need to manage mass emergencies, where people need to be evacuated within a short period of time. We're facing many challenges in relation to crowd management. One of the most important one of those challenges is the fact that we are dealing with human behavior, and representation of human behavior in simulation models is not an easy task. You're dealing with a complex situation. People show a variety of behavior, and that has to be included in our modeling capabilities in order for us to be able to have an accurate representation of their behavior. And in obtaining an accurate picture of their behavior, one of the key challenges that we are facing is the lack of data. And I'll show you how we have dealt with those challenges in the research within the next few slides. So what I am showing to you here is essentially the end product of the numerical simulation tool that has been developed at the University of Melbourne for simulation and modeling of pedestrian crowds during various scenarios, including emergency situations. And what you see here as the final product is the result of layers upon layers of models working together in concert. So we have layers of models that represent momentarily mechanical movement aspects of people's behavior. We have layers of models that represent different aspects of their decision making, which direction they take, how do they respond to the crowded areas, when do they decide to change their decision, and how do they go about changing those decisions. So you see these models working together, and models that are of very different natures. For example, we have models that have been borrowed from notions of statistical mechanics and physics, and models that are borrowed from models of decision making in economic contexts. But the most important aspect is that how do we make sure that these models are accurate, and how do we make sure that the parameters of the model are fine-tuned in a way that they represent reality in a fairly accurate fashion? Well, we resort to experimentation. So one of the key aspects of our work is the fact that we create different scenarios that we think are important in terms of the accuracy of crowd models in laboratory scenarios, in controlled situations, and we replicate them with actual crowds of people in those controlled environments in order to be able to later on investigate their behavior with accuracy and detail. These scenarios could be scenarios such as emergency evacuations, such as evacuations of people from enclosed spaces, or scenarios where various streams of people have to be shared and make a conflict, which is a quite common feature of, for example, when stadiums get evacuated, when large venues get evacuated. So these kind of experimentations have enabled us to look at the behavior behavior to increase the accuracy of our model. We call it the process of validation and calibration. And this has been in the heart of this research, that we link theoretical developments to experimentation and empirical work to make sure that the accuracy of our model is solid. And whenever we cannot replicate the behavior of people in such environments, we resort to virtual reality experiments, as you see in the slides below. But what are the applications of such numerical models that we have developed here? There are numerous applications. I call them mathematical optimization, architectural optimization, and behavioral optimization. There are 3 different avenues that we can think of that can be utilized to help people move faster and more and safer. For example, you can schedule the departure time of people at a large venue in a way that the final outcome of the movement is optimized. That can be done by implementation of the numerical models in a mathematical optimization model and identifying an optimum scheduling pattern. Or you can make local modifications to the architecture of the building and make that more suitable for the behavior of people. And most importantly, the most modern approach that I'm taking in this research is the notion of behavioral optimization. How can we equip individual people with the knowledge that they can utilize so that when they demonstrate that the kind of behavior that we are instructing, the final outcome of their movement is optimal. I call that behavioral optimization. And all of these areas can be done using the same numerical model that I showed you. But facing the COVID crisis, we have moved to some topics that were not a focus of our attention a year ago or so. And these are related to issues linked to the risk of disease transmission, for example, in pedestrian facilities. This is a new topic that has been introduced to us since the COVID crisis. And in a collaborative work that we have been doing with Arrow, we basically are looking at how we can develop secondary models that can be utilized with any crowd simulation output in order for us to be able to identify areas where risk of disease transmission is highest. So we have developed secondary models, and that can be integrated with any standard simulation model, and we can visualize outcomes that shows where severe breaches of, for example, physical distancing is highly likely to occur during the movement of people, and where, for example, sustained exposure of people during the movement of people can be expected. These are the kind of metrics that were not our focus before the COVID crisis, but with these new issues in the world, we are looking into those and developing models that can represent these issues on an objective basis, so that researchers, so that policymakers can use them for making recommendations and designing scenarios that would prevent disease transmission, essentially. And this is again, I emphasize that this is a collaborative work that we have been doing with Arrow recently. This concludes my presentation. I now hand it over to Stuart, and I'll be happy to answer your questions during the Q&A. Thank you.
Hi there, everybody. What I'm going to do is spend just a few brief minutes looking at some work that we have been undertaking around what we call situational awareness in urban systems. And in fact, more or less sort of aligns and builds upon the previous presentation around how we can use advanced models and analytics to be able to sort of improve our decision-making capability in real time and hopefully actually ahead of events actually occurring within the built environment, within our urban system currently. Next slide, please. So what I'm going to cover today is essentially approach which is sort of based around that of the real-time digital twin, and in particular thinking around the aspects of the UK Gemini's principles, which sort of defined 2 types of digital twin, but in specifically a dynamic digital twin where we have real-time input of the current performance of our urban system, our built environment, in regards to things like the physical flows, movements, interactions, and events that are taking place. And then via those measurements and that monitoring through sensors, IoT and edge computing, we're able to feed back into the physical system in terms of our ability to make decisions in real time and be adaptive around the events that are taking place within the built environment. And so what we're focusing on here in the material I'm going to present is essentially the top two layers and their interaction within the Gemini's principles pyramid. That's the analytics and modeling layer, and also the decision-making layer right at the top. And how do we couple those two together to make better informed adaptive decisions in real time? Next slide, please. So what I thought I'd try and do is, rather than do this in an abstract way, I thought I'd try and walk through and talk through a real example of some work that I've done back in the United Kingdom with colleagues around improving our situational awareness around extreme convective rainstorm events. These are events which happen over very short duration but have very high magnitude. They are highly spatially and temporally variable. So in one part of the city, you may be receiving up to 50 millimeters of rainfall over a relatively short time period, for example, an hour. And maybe 500-600 meters away, you may not get any rainfall at all. And so their impacts are very locationally based, but when they do occur, they have an extreme impact and propagate through the entire urban system. And so what you can see in this overhead is actually a real event that took place within the UK in the city of Newcastle. So how would we start to address this? Well, maybe first of all, we want to start off with being able to monitor the event. Next slide, please. So we need some way of monitoring the evolution of our extreme rainfall events. So in this particular case, utilising short-range weather radar data to understand how the convective rainstorm events is developing. We then need a means by which we can then nowcast or simulate how the event's going to develop. We then would couple that to a hydrodynamic surface water flooding model to understand where we're going to get flooding taking place, and then use that output from the flooding model to actually then undertake our situational awareness, to start to monitor our road network with regards to the potential impacts that we might expect to see or will be seeing into the future, so that we can actually then allocate and look at those areas within the urban system where we need to take adaptive measures in real time. Next slide, please. So in the work that we've undertaken looking at situational awareness, we've actually now built a start-to-end demonstrator. This demonstrator is continuously running for the city of Newcastle back in the UK. We take real-time data feeds from the short-range weather radar. We use that to trigger our modelling environment for the rainfall model to predict where we're going to get rainfall events. That in turn is used to parameterize a highly optimized and speeded up hydrodynamic surface water flooding model. And then we use that then to actually undertake our monitoring through the traffic video and local CCTV network in order to actually undertake traffic counting and to model and simulate how traffic congestion may propagate over the road network as a result of our predictions of where we're going to see the rainfall event taking place. And so, as I said, we've now built this start-to-end workflow that is running in real time and actually using it to continuously monitor our adaptive and situational awareness for the city of Newcastle. I'd just like to sort of maybe finish off with a couple of future directions. One is around improving our ability in real time to make adaptive decisions and look at the various options around intervention within an entire urban system which is highly complex. And so we're looking at how you can take existing approaches around optimization, and in particular this approach you can see here called Pareto optimization, to look at the different intervention options and the various trade-offs of those within multi-objective dimensions. So maybe an intervention in one dimension, one axis you can see here, will have a negative impact on the other dimension. So understanding those trade-offs that we have to make. And also, next slide, please. And then finally, looking at the types of decision support tools that we should be building in order to allow decision makers to make decisions and be adaptive around situational awareness in real time. So what dashboards and integrated decision frameworks do we require, where we're coupling advanced modeling and simulation. As you can see here on the left, our surface water flooding model running in real time with video and CCTV input to where we have a particular area of severe water inundation. And then on the right-hand side, coupling our agent-based models, similar to the approaches you saw in the previous presentation, with understanding around the disruptive events that are occurring over our transport network. So that's it from me. Very happy to discuss further any questions around situational awareness and the type of modelling and workflows that we can develop in order to improve it within this sort of nowcasting modelling and simulation framework.
Thank you very much, Stuart, and also rest of the team. I'm also very delighted to have this opportunity to meeting all of you today. And I hope that by now you have received a snapshot of some of the projects and also activities and capabilities that our team have been working and investigating on, have already addressed some of your interests. What I would like to finish it off the webinar before we addressing some of questions would be about our future directions. In fact, I'm going to just listing some domains that would be directly relevant to the digital twin. And this is a center that we are proud of our close collaboration with industry and governments, and therefore we would welcome any type of opportunities that anyone have or wanted to discuss further on any aspects of the work that we have shared today. Next slide, please. So some of the areas that we are focusing on, one is about the launching digital lab. This is the D lab. This is about the different approaches for communicating the results, and in particular with our new building that we are moving on to this by mid next month. We're going to have a digital lab specifically for the series of capabilities that we can offer to our industry. That again, showing series of functions at the same time, tools, and we continue our work with the industries around that. So we will be calling for this, and we'll be sharing with you that particular D lab launch. Also, our colleagues already discussed about the e-planning and e-approvals project, which is the project, again, in close collaboration with industry under the Building 4.0 CRC. We're continuing our work on the 3D underground asset projects, and this is the one that we also having a very close collaboration with a number of agencies. And also we're waiting for the result of another bid that we have made to, and hopefully we can expand this functionality. From the computational infrastructure, this is the one that in collaboration with 5 other universities, we are very happy that we put a big project to federal governments, and this is about the increasing the level of capabilities and bringing together the complementary skill set and also capabilities from different parties to delivering and providing a new infrastructure to our communities and also to wider industry. And in fact, this particular will be perhaps linked with the ORIN, which is the one that Professor Stuart Barr as director of, with the expansion of the series of capability that exists in our university and in Australia to serving wider urban system and also urban planning groups. We're also working on data models, and this is about modernization of the land and property system and series of models that actually can work not only for the assets above ground, also for underground assets, and in addition to that, also interaction between indoor and outdoor. We also continue our efforts around the expansion of the capabilities for the communication from VR, AR, and series of other capabilities that would be complementary into these domains. And we also now expanding our work not only from the physical space that we create in the digital twin, we also connecting that to the human space. So this is another work with another team in biomedical and also biomechanical team that we're trying to bring a total solution that would support aged cares, child cares, as well as also injured people. So therefore, we are bringing and connecting series of new capabilities that hopefully we changing the way that we operate and also providing new type of views for our decision maker as well as also wider societies. Definitely, we're welcoming any type of partnership arrangements, and we couldn't make any progress if we didn't have the partnership and also the trust and support from our industries. So we appreciate all of our colleagues and industries that have been working with us over the last 20 years. And this is the one that we also going to, again, as I said at the beginning, to celebrating our 20 years, which will be in September, which we will be announcing the details very soon. So by this, I would like now to open up any question and answer, although I have seen that series of questions have already been responded by our colleagues here in the background. But if there are any other points, please proceed with that and share with us, and we can respond to this. And you have our details. You can contact us at any time. And we, as we mentioned, we will be posting the video of this webinar through our website that you can also use. And again, any other points that you have, you want to just discuss with us and get some views, we would be very happy to do that. Sohail, do you want to manage
Thank
this?
you very much, Abbas and the entire team. And as Abbas mentioned, we already answered a number of questions, and we are happy to take further questions if you have any. And I actually shared the website of the CSDILA as well as our LinkedIn as well as the newsletter with all. So we are very happy to having a further conversation about the detail. If you are interested to be engaged with us, we are very welcoming, and we have different strategies for engaging with industries in different venues. So if you have any question, please feel free to write. So we'll take those questions. But while we are waiting for the questions to come, just asking some of those questions to our panel. We actually have questions regarding to the roadmap on the development, and I would like to asking Abbas to talk a little bit on that, about the roadmap on the development of the digital twin and perhaps implementation in the federal level.
Thank you very much, Sohail. Very happy to answer this. As I've indicated about some of the elements for our future directions and work, we have a very clear strategic pathways and also roadmap for the expansion and advancement of the digital twin with the capabilities coming from the different sources. And this is the one that we are also providing this into a number of other jurisdictions outside Australia as well. And also we're providing, and we're hoping that, again, we're continuing our close collaboration with a number of agencies and governments to providing and helping our governments at different levels, from local level to council, into the state and into the national, to making sure that we're also contributing from our end to advancing this platform for whole Australia, and of course also helping and interacting with other jurisdictions. And right now there are 4 other countries have been in discussion, and also we have settled a number of those, but also again expanding some capabilities into the other jurisdiction. So, and at the same time, we're also learning from those as well, because again, this is a system that is going to be live, and then getting, and the beauty of this and the value of this is when you have interacting with that, and the system gets mature and mature every time you interact with that. So therefore the system, as we add more functions and the sensors connected to this, we would actually get a more power to deal with our, with our jurisdiction, with our decisions, and the way that we can advance, and also minimizing the effort, but maximizing the return on the investment. And Victoria is already actually expanding, and Land Use Victoria has been great, again, working in this domain with a number of agencies, and also, again, a number of other domains that actually have been contributing. And I'm very pleased to see that in the market, there are many agencies and also groups, private sectors and others are focusing at and also advancing this work. But again, the partnership arrangements around this would be the most important to making sure that we just connecting the capabilities together to advancing and strengthening our capabilities.
Thank you very much for answering this, Abbas. There is a question regarding to the accuracy of the digital twin. I would like to ask Benny to elaborate a little bit on that.
Thank you.
Sure, Sahel. Yes, for that is absolutely great question. The accuracy of digital twin, I believe it has several folds means. First of all is the data accuracy. So because as you can say, what we demonstrate in our session is all about the platform itself. We're building this platform to host many different data sets. We are not the data providers. We are like the platform providers. So a lot of data accuracy issues, we probably cannot give you direct answers, but so we encourage all the data the data owners who is using the digital twin to provide the most detailed metadata to describe the data sets, and this will ensure all these sort of concerns about the digital the data sets available on digital twin to the end users. Another level of accuracy could be the models. So we did, for example, provide many building models like the solar access, the shadow analysis models. So when we release these models, we certainly double checked, the accuracy of the data, and we do have our internal Q&S process to ensure whatever the model we provided on the digital twin meets the minimum requirement. Yeah.
I'm sorry, I think we have received a number of questions, but perhaps we need to answer only one, and then perhaps we have to wrap up the entire session. So there is a question about the spaceman. The question is, I'm wondering, is it built primarily around GIS dashboard and connecting a number of APIs, or built the application platform for the ground up? Behzad, you can actually answer this question, please.
Well, the Spaceman is actually connected to the variety of APIs, and also, so it has different facades. One is actually something that we build it ourselves, and then the data is coming from APIs. There has been different sprint of that. There was a sprint that actually, I think the video that I showed was basically showing or using some of the 2D maps, but then we moved away from that. At the moment, if you go to the Spaceman, you don't see that anymore. It's fully immersed and it's fully 3D. Of course, in different sprint, we used and we tested different systems, but at the moment it is fully 3D and fully in-house. But of course, for the data, we are getting API access. I mean, Benny would be able to correct me if I'm wrong.
You're absolutely correct.
Thank you very much. And I hand it over to Abbas to finish the session.
Thank you very much again, the entire team, and also would like to extend again warm thanks to all of you that have been attending and spending time with us today. And I hope that again you have achieved and also heard something relevant to your domain of activities, and we would be very happy again to catching up with you. Just contact us and we would be very happy to set a time to meet and discuss and see what we can do and provide you with the details. Thank you very much. I would like to say goodbye to all of you and stay well and look forward to seeing you in near future. Thank you.
Thank you.